Today we did an experiment displaying the abilities of creating potential energy with fluid and how height affects it rather than volume of the fluid. So today the temperature was 15.6 degrees Celsius, putting our density of water at 999 kilograms per meter cubed. To this we had a PVC pipe and a 5-gallon bucket, and we put pressure gauges at the bottom of each device. The height of our PVC pipe was 4 meters, giving us a volume of 0.18927 meters cubed. To find the potential energy at the bottom of the device, or the pressure, we multiply the density by the force of gravity by the height of the fluid. So 999 times 9.81 times 4, giving us a pressure of 39.2 kilopascals, which converts over to PSI, 6 PSI. We use PSI because the gauges we use in that experiment that we'll show later is in PSI. For our second device, our 5-gallon bucket, it has a height of 0.3683 meters and has a volume of 0.18927 meters cubed, which is the same as our PVC pipe. When we go to find the pressure at the bottom of this device, we multiply the 999 times 9.81 times 0.683. This gives us a pressure of 3.6 kilopascals, or 0.5 psi. In this experiment, we show that each device has the same volume, but the difference in height at the top of the water is what creates the pressure at the bottom of the device. Similar to what you would see in a water tower. How it's actually not that much volume of water, but it's the height that creates pressure for the area around it. So with the same volume, we can have a much higher pressure. So here you can see the PVC pipe I used. Before standing it up straight, I secured the water hose into it so that I could turn on the water hose and let it fill instead of standing on the ladder. And while it's still filling, holding on to it to make sure it doesn't fall over. I had previously filled a 5-gallon bucket of water without a gauge on it, so that it'd be easier to fill my bucket with the gauge and get the measurement at the same time as the pipe. Now I'm just waiting on the pipe to finish filling. Alright. Now it's overflowed some, I know that it's full. Here you can see our experimental value is around 6, which is close to our theoretical. And for this one it is under 1, so we assumed it was near 0.5. And here's an image of the full contraption.